Hi friends, this is Soft Reason. In this lesson, we will be doing a model of this kind, okay? And we will be doing analysis and then design this model in a special way so as for us to be able to get our calculation sheet, okay? So I will teach you my own way of designing a steel member in a special way, just like this, okay? Just like I want to get my calculation sheet of this, I will just come to this point and then I will view my design result table. Okay, so these are the table, this bar after, and this my stick column. This is original section and this is the design section. Okay, after the programs must have design selected this section, you can see slenderness, check pass, and every other thing. So this is what we will be doing, and as well too, you can click on this, right click, and then you check your view calculation sheet. Okay, you have something like the design of member number this as per BS 5950. Okay, if we scroll down also, you notice that everything as per statute of everything, passed. Okay, so this is what we will be doing in this particular lesson. You can see we are going to print as well. Okay, we have these informations, okay, printed already, okay, in PDF. Okay, so you can attach to your attach it to your drawing and then send it to your clients. Okay, so this is what we are going to be doing. So let's start, and then we go to new. Okay, I click space. Okay, and then we enter training. Okay, then after which you have to check your units. Okay, then you click next, and again you need to know where your drawing is saving. Okay, alright, so you can just click on this point to check where you are drawing new folder inside of my document. Okay, so you nest it and then you create a beam. Alright, so it asks me to save the original say yes. Alright, so at this point we want to model our frame. Okay, you click at this point and then we want the height of 4 meter for our stanchion, and then we are considering length of 10 meter. Okay, we'll be considering length 10 meter. Alright, we'll do something like this. Okay, and so after which we close the grids. Okay, and so the next thing we do, we want to create a node here. So you click on this beam. Okay, right click and then insert node. Okay, now you select hard midpoint. Okay, the midpoint is 5 meter. Okay, so you click on okay, it has added a midpoint. Okay, and then you click on the node cursor, you align the node. Okay, we are going to assume a height of 2.5. Okay, height of 2.8 meter. Okay, as in our reach. Okay, so we align the node, right click, and then we have to move the node in the directions y axis. Okay, we move the node in the direction y axis. Okay, and then you will put a 2.8 meter. Okay, and then we click on okay. Okay, so this is what we will have. Okay, the next thing we need to do, we want to go to general. Okay, in this general we are going to select this section database just for our properties. Okay, and then you click on section database. Section database have shown up, so we are dealing with British code. Okay, so we are going to be using a UV shape. Okay, universal beam. Okay, we want to select one of the smallest sections. Okay, like this. Okay, this particular one, 178 by 102, and then we will add. Okay, and we closed. We want to assign this to all the structure for the sake of this lesson. Okay, so we will click on assign to view. Okay, and then we assign it to view. Okay, so after which we will close this. We will go to our support. Okay, you create a fixed support, you add. Okay, and then you select this. Okay, you assign to the selected node, or you just go this way. Okay, select both the nodes and then you assign your support. Okay, the next thing we do, we go to our loading. Okay, you click on the load case detail and then you add. Okay, you select your dead load, save the structure DR, and then you add, go to live load and then you add, okay, and you closed, okay. Click on the DL beneath the dead load, you add, okay. Then this is our self weight, okay, so you also add this, okay, and then you go to your member load, okay, in the directions of global y axis, okay. You do minus because it is acting downward. Do 1.8, okay, 1.8 kilonewton per meter, okay. You add, you closed, okay. You come to close this, you come to live load, you add, okay, and then you go to member load, okay, in the same directions, okay, and then you type minus 1.5, okay, which is our live load, okay. You add, okay, you closed it. All right, so you click on this self weight and then you assign it to view, okay. All right, so you view your model in orthographic directions. Select this and then use cursor, all right, to assign. All right, then you assign it here, assign it here. You do the same thing, yeah, okay. You also assign it. All right, and then you click on okay, okay, to exit it. All right, so if you do control shift and then V, it will give you these loadings, okay. All right, so the next thing we need to do, we want to add our load combinations, okay. So you click on auto load combinations and then you select the British code, okay, BSX B5950, okay. Then you generate your code. Now in this code generated, you notice that this is for concrete, okay, 1.4 factors and 1.6. This is for concrete and it is used to design a concrete member. So you bring it to this side. We are not going to make use of this. And this one is used to design foundations, 1.4, okay. We are not going to make use of it. So this is what we are going to make use in this design, okay. So you add it, okay, you closed, okay. So after which, the next thing you need to do is you will go to analysis and print, okay. You click on the analysis and print. You had said perform analysis. That is the only thing we are going to add in this lesson, because we are looking up to designing our steel members and get our calculation sheet, okay. So you close this. All right, you click on the drawing background and then you go to analysis. You click on run analysis, okay. You save the project, okay, and then observe the project running analysis, checking for errors, checking for warnings, checking for notes, okay. So the analysis is successful. You have 0 error, you have a 0 warning, you also have a 0 note, okay. So we want to go to post-processing mode, okay. So you click on post-processing mode and then you click on done, okay. Okay, so you come to this result view options, you click on it. You come to enable automatic scaling, you click on it and then you check your shear and your bending, okay. So you apply and then okay. So this is what you have. This is the deflections based on the load applied to this particular frame, okay. So you can check your bending moment, okay. So these are bend moments, okay, in these directions. You can also check it in other directions. You want to see your reactions, you click this point, you can see your reactions, okay. All right, in the y direction, okay. So the next thing we are going to do, which is the most important, we are going to steel design, okay. So you click on the steel design. Mind you, you can take picture of some of these things and add them in your report by clicking on this take picture, okay. You can give the picture a name, okay. You can just say reactions. All right, I just say reactions, okay, picture 1, and then you add. It has added it into of your printing setup. By the time we get there, you will see this, okay. Just for an example, for the sake of this lesson, okay. So the next thing we are going to do is we go to steel design, okay. At this point now, I would like us to dimension this our inclined beam, okay. So we click on this this icon for our dimension. All right, we are having 5.73. If you check this point, we are having also 5.73. all right, okay. So what we need to do now is we are going to exit this, okay, and then we go to new envelope. We want to create an envelope. So this is our combinations. You check it, okay, and you can also change this name of your envelope, but I want to leave it as design envelope 1, okay. So you click okay. At this point you want to move to the next point. The next point is member design, okay. So you click on the member design. In the member design, you first of all create members, as in you assign name to all these members. For example, you are doing a full structure, you have to assign name to all of these members, okay. So I want to do automatic form member, okay, but you can do form member one by one as well, but in this lesson I want to use automatic form member. So they will tell you no member selected, okay. But if you want to form members one by one, you need to select and then you form, okay, using this icon. So I want to form automatic, I say yes. So I have about 4 members, okay. Alright, so the next thing I need to do is I want to go to my brief and group. Okay, click on my brief and group. Okay, I want to set a new brief. I click on this new brief. Once I click on the new brief, I will have this, and then design code I have to change it to BS 5950 part 2000. Okay, so I want to begin to edit this from here. Alright, so what I have here is T grade 29275, which is what I'm going to use. Is okay. Alright, for the sake of economics. Okay, then I'll go to my steel strength. This design strength of steel is 279,000 kilonewton per meter square. Okay, so this is what I'm going to use. Then my radius observation lag length. Okay, now I want to tell you how you can get this value. Okay, so you can get this value. This value have a multiplication factors of 0.75. You check in your steel handbook design manual. Okay, this multiplication factor, you use it to multiply the length of this your inclined beam. Okay, then you'll be able to get this value. So we want to do that now. You go to my calculator. Okay, I break up my calculator, and then the multiplication factor is 0.75. Okay, I use it to multiply 5.73. Okay, all right, and then I okay, so I'm having 4.297. Okay, as my lag length. 4.29, sorry, 4.297. All right, so that is taken care. Okay, so that is how you get this your leg length. Okay, so you go to this one is okay, single line fastening. So the maximum allowable depth. Okay, I want to tell the program that I want the program not to exceed 30. Sorry, I want to tell the program I don't want the program to exceed 0.303 mm. Okay, so this is a stitch section that I don't want the program to exceed. That is why it is called maximum allowable depth of this particular stick section member. Okay, all right, so I don't want the program to exceed this. Okay, so you check your minimum is 0, NSC is 1. Okay, all of these are okay. No slenderness check. Okay, so we want to do a slenderness check of the main structural member. Okay, if you are doing a full structure, you can create different briefs. Okay, where you can do a slenderness check based on bracing. If you are having bracing in the structures, in the next video we will look at that. Okay, for now we select main structural member. Okay, so we check the ratio. All right, the ratio is 1. Now the next thing we should be looking at is we will be looking at this. We have deflection limit. Okay, now for you to be able to get your deflection limit value is 1/360 times this length of this beam. Okay, so we want to check that in our calculator to see what it gives to us. Okay, and then you do 1 device 360. Okay, sorry, 1 device 360. Okay, equals, you have this. Okay, then you multiply this by this length. Okay, which is 5.73. Okay, and then you hit on the equals button. You have a 0.0159. 0.0159. Okay, so that is what we are going to input in this place. Okay, 0.0159. Okay, so this is our deflection limit. Then you check again the beam. All right, this is okay. All right, select types, row, want to use weight. Okay, in this place. Okay, weighted / built up sections. Okay, then check this. All right, this is okay. Also check this. Okay, transverse stiffener spacing without stiffener in this design. Okay, so we leave that. Okay, equivalent in a uniform moment factors. Okay, all right, all of these are okay. We don't have any more to leave. All of these are default. Okay, then you click on OK button. All right, so after you must have identified your briefs. Okay, you can do 1 brief, 2 brief, 4 briefs as well, and design it, use it for your design according to your design group. Okay, so now you want to create a design group. Okay, for us to do that, we have to click on this new design group. Once you click on this, you give your group a name. Like if I want to design this is my rafter. Okay, so I will type rafter. Okay, sorry, rafter. All right, and then I will add. So what are the rafters? I'm having member 1, 1, 2, 1 and 3 as my stick columns, and then member 2 and 4 will be the rafter, which is covered by this dimension. Okay, so you select 2, add 4, add. Okay, these are my rafter. Okay, so you okay it, you create new design group again, give it another name again. This time it's going to be steel column. Okay, then you add these steel columns under it. All right. Alright, so you add a M3 member 3, and then we are going to also add member 1. You add, then you okay. Alright, since you have added all of this, you can be able to identify your rafter and your columns. Okay, so what next you need to do is you come to this member design. Okay, you click in the drop down menu, you see perform group designs. Okay, you first check code. Alright, see group design completed successfully. Okay, you click okay, you go back again, and then you do member selections, single step design, and you click okay, group design completed successfully, you okay. All right, so at this point these members has been designed successfully, so you want to check. Okay, for us to check, you go back to member design, you click okay, and then you come to view design result table, you click. All right, so once you view that design result table, this is what you will have. Okay, you will notice that this is what we selected and assigned to these members, which is our original sections. Then after design, you see our design sections. The programs have selected a design section based on the load on the frame. Okay, and so you can check all of this. You will discover that this is a slender check as passed. You can check combine as here, everything has passed. All right, so the next thing we are going to do, you want to view this individually, so you close this window, you select this. Mind you, before you select, the members cursor must be activated. If you are using this cursor, you will not be able to get what you want. It can be selected, but it will not give you what you want. Okay, so you have to activate your member cursor. Okay, and then you click on it, you right click, and then you view design calculations. Okay, so this is your design calculations. All right, this is your design calculation. You can see all the check, slenderness check safe. All right, web check for serviceability safe. Okay, compression flange buckling check safe. Okay, minor exist shear check safe. All of the check is safe. All right, and finally when you come downward, you see and notice that the result pass. Okay, so this is what we will be printing. So after this stage, we are going to do a printing. Okay, we are going to do a printing. For us to do a printing, you have to go to your file. Okay, once you click on your file, the next thing you need to do is you come to printer report setup. Okay, once you click the report setup, this already job informations. Mind you, we didn't fill any job informations. Okay, so you will see it blank. Okay, so this is the input sections you add. Okay, that is what we'll add here. So we'll come down, you go to outputs. Okay, or you come to picture. You notice it was only one picture we took in this design. Okay, so you add it. All right, so you come down again, check output. All right, in this output, what we need to add, there are too many things to add, but we will be adding our reactions, the reaction summary. Okay, and what again, I think that is it for now. All right, you can add other things when you are doing a full design. Okay, so you click here. The next thing we are going to add is steel design output. All right, so that we can, this is for member 1, you add, this is the columns. Okay, for member 4. Okay, for member 4, which is the rafter, one of the rafter, you add. Okay, so after you finish adding this, okay, you click on print. Okay, click on print, you go to property. Okay, you can set your paper size. Okay, depending on the paper size you want to use. Okay, and then you click on print. Okay, so it asking you to save this, so the name of the file will be training printing file. Okay, all right, so we save it inside of my document. Click on save, so it's going to print this in PDF, where you can print it out and attach. If this lesson has helped you in one way or the other, kindly subscribe, like the video for more videos. Okay, I do advanced videos in engineering, using engineering software. Okay, so this lesson is helpful to you. So this is the picture we took. Okay, all right, so this one is the reactions. All right, in all the directions and the movement as well. Okay, this is the reaction summary. All right, so this is the main thing, which is the design of member 1. Okay, Remember, this member 1 is the column. Okay, so this is what it is given us. All right, so these are the calculation sheet. Okay, all right. So this is design of member 4, which is one of the rafter. It is giving us 254 by 146 by 3 by 31 millimeter. Okay, so if you check, all the components are safe. Okay, all right. So this lesson has helped you one way or the other. Kindly subscribe, share the video, like it for more videos. Don't forget to subscribe. Okay, all right, bye.